Alright, so we talked about that periodic table there, and we were specifically talking about carbon. We talked about the orbitals, and that carbon is somewhat unique because it has 6 electrons, and it has 4 available slots where it can, make bonds with other elements. So if we look at something like oxygen, then the first orbital is going to hold 2 electrons, and that gives us 6 electrons that are left, but it's not full. So let's look at something like CO2, right? So this comes down to, why are there 2 oxygens to 1 carbon? Alright, so carbon, remember, can hold, let's make our carbon atom. There's our nucleus. Okay. And then we're going to have 2 oxygen. We're going to make our oxygen atoms here, like this. Okay, something like that. It's not exact, but we're going to get the idea. Alright, because we don't need to get big time into the chemistry. We're going to save that for the chemistry teachers. But remember, we had 2 electrons here. That one's full, and then we had 4 left over here, but it's not full. It's not full. Remember that the second orbital wants to hold 8 electrons. It likes 8. It wants to be full, just like us after a turkey dinner, right? So these are our oxygen, and it's got 2 there, and it's full. But remember, oxygen had an atomic number of 8. Okay, so we put 2. That leaves us with 6 left over. Alright, so we're going to go, there's 1, there's 2, here's 3, here's 4, and we have 5 and 6. Okay, but we have empty spots there, and the same thing over here. So we have 2 here, and then we have 1, 2, 3, 4, and we have a couple left over. Okay, so what's going to happen? Well, these electrons are then going to end up being shared. Okay, so this one is going to move over a little bit, right? And we're going to get 1 here, and it's going to share it with this oxygen atom. And these 2 here are going to come in and be shared with this oxygen atom. Okay, so then, because they're sharing, right, they're not too selfish here, they're sharing. And since they're sharing these electrons, that means that everybody ends up with a full outer shell. So let me draw this a little bit better for you. Alright, so we're going to have our carbon right in the middle, and I'm just going to draw, let me start over there, and let me just draw the outermost orbitals here. Okay, our valence electrons, that's what that's called. The outermost orbitals are called our valence or valence electrons. Okay, so these are the ones that, remember that the first orbital is full, the one that only holds 2. So we move to the second orbital, and that's all I'm drawing at this time is the second orbital. Okay, so this is our carbon right here, and this is an oxygen, and this is an oxygen. Alright, so this carbon has 4 valence electrons, and this oxygen has 6, and this oxygen has 6. Okay, so let's draw this out. There's 1, there's 2, here's 3, 4, 5, 6. Right, and let's do this oxygen, 2, 3, 4, 5, 6. Alright, and now this carbon has 2, so it's going to put 2 over here and 2 over here. Now remember, these are much closer together. I'm just drawing a crude drawing here, alright? So therefore, this is going to share right there, and this is going to share right here. So we end up with our CO2. Alright, so this is what the big deal is about carbon. Carbon can also actually bond to itself. Okay, and we're going to talk about that some more later on. So if carbon's valence electrons or valence electrons are the ones at the outermost, right? They're the outermost electrons. Okay, the outermost on at the very last orbital. Okay, and carbon has 4. and 4. So 4 and 4 equals 8, and it would be nice and happy because it would end up with 8. So this is also what makes carbon very special, is because it can bond with itself, and it doesn't mind. It likes to bond with itself, okay? And we'll talk about that some more as we get into our macromolecules on the next video.